So here's our last example from this section. I'm going to show you again how to do a tree diagram and how to figure out probabilities using that as well, if that's helpful for you. A student placement center has requests from 5 students for interviews regarding employment with a consulting firm. 3 of these students are math majors and the other 2 students are statistics majors. Unfortunately, the interviewer only has time to talk to 2 of the students. These 2 will be randomly selected from among the 5. So again, you are not being able to choose the same student. They're exclusive events. You're picking 2. I just wanted to show you the sample space and how I came up with this. So if you're not quite sure where to get started, I guess I would begin with the tree diagram. Some of you are going to get this much quicker than others, but I'm going to give you just some different tools to use. So here's an example of the tree diagram. S1 stands for Statistics Student 1, Statistics Student 2, Math Student 1, Math Student 2, Math Student 3. So on the first pick, he's going to pick one of here, and then on the second choice, these are the choices. If you're this first statistics student, then I can only pick the second one or any 3 of the math. Same here, the first, second statistic, I can choose the first and any 3 of the math and so on. So you kind of see the pattern. There's 4 outcomes for each specific case. So 4 times 5, I'm going to have a total of 20 outcomes in my sample space. And then I just went ahead and listed it out for you here as well. Okay, and I'll come back to this. But S1, S2 would be both statistics students were drawn. So let's go back to the slide and see what our questions are asking. What's the probability that both selected students are statistic majors? So if both selected students are statistics majors, let's go back to our slide that shows all the sample space. We are only looking at, out of the 20 outcomes, which ones have statistics student 1 and 2. And so in this particular case, I would use this outcome and this outcome. Out of all the ones, those are the only 2 that have both statistics students. So I'm going to go ahead and say then that the probability that both selected students are statistics majors is going to be 2 outcomes out of 20, which is equal to 1/10 or 0.1. What's the probability that both students are math majors? So let's go back to our outcomes. And again, we have 20 outcomes. And now we're talking about the cases where we just have 2 M's. So all of these rows are going to be out. In here, I'm going to have 2. Here, I'm going to have 2. Here, I'm also going to have 2. So there's a total of 6 of them out of the 20 that would have both math majors. Okay, so a little bit better because there's more of them. So 0.3 would be my probability. The probability that at least one of the students selected is a statistics major. So at least one means one or more, remember. So I'm going to go back to my outcomes and I'm looking for ordered pairs that have at least one S in them. So I would choose that one, that one, that one, and that one. So 4 there, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 of the 20 are going to have at least one of the students being a statistics major. That's 70% or 0.7. What's the probability that the selected students have different majors? So now we're going back to our sample space and looking for those that have different majors, so an S or an M. And those are the ones we're going to highlight in blue here. So an S or an M would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 out of 20, or 0.6, are going to have the probability that have different majors. Now you could also kind of do the complement there. So you know the probability that both are statistics was 2/20ths, and you know that the both were math majors was 6/20ths. So together you had double majors as 8 out of the 20. And you could, and rather than adding up all of those, you could take 1 minus the 8/20ths to get you the ones that are different majors. That's the complement part to that. And you would end up getting the same answer, 12/20ths, which would be 0.6. So again, you could take 1 minus 8/20ths, or 20/20ths minus 8/20ths to get 12/20ths, or 0.6, using the complement method.